So I used to work for this guy right here. He abandoned me, so it doesn't count. so
It's your fault.
It's just like my dad. He ran away. So this is technically myself and the David Collion. He's not here. Bishop Fox, we test things. You can go find one of the salespeople. They will sell you a test. I can't do that. So we're just doing this as a tool release, and we're going to talk about what we did. We don't want to sell you. I don't want to sell you things because I'm lazy and I don't want to work. That's the agenda. Okay, so like take a second. David Collion, he couldn't be here. There's nothing wrong with him. He's just in Japan screwing around. But, you know, pour one out for our homies. You can hand me the remote mic. I like to move around. Okay. Does it work now? I don't like to be tied down too much. So what happened was we were testing a manufacturing client. They basically said, you can test anything you want. David called me and said, hey, I think there's this Sparkplug client. I don't know what to do with it. So the trifecta is, it's an anonymous broker, which means anyone can publish data and anyone can become any host on this network. The devices accept like mid-auth or like kind of mid-sequence. You can just take it over mid. There's no like collisions or anything. And also, they're connecting their enterprise network directly into their sensor network. Don't do any of these things. If you were running a sensor network, just don't do those and you'll be fine. So MQTT, also everyone else who, I was shamed yesterday. I walked to all of the other speakers' talks. They were great. I immediately went back to the hotel and added a bunch of these slides. Like, I was just gonna come up here and like throw it together, and nobody else had done that. So this is a like version 2 better slide deck. So Sparkplug runs over MQTT, commonly called Mosquito, which calls back to the name of the talk because we're funny. So basically what it does is it takes a protocol buffer, with the proto buff, smashes it together, makes it very short, but instead of having like a humidity sensor, which I have some in the back there, we're gonna show that during the demo. The field name will be like 1, and at the end, it'll know that 1 is the humidity sensor, and then it'll put the value in there. So without like a defining thing, with just like a number, super great because you don't need to know what it is, you just need to know that it's a 1. And then the topic namespace, which you can just sniff, which is great. So this is an example. So like Sparkplug B version 1, the group, we're gonna show a couple groups, the message type, node names and device names. That is what you will see on the network. So it defined fields in a binary format. It's great to fuzz. And then it had 9 message types, 19 data types, and the 87 fields. So here's some stuff we're talking about, proto-buffs. Does anyone actually have questions about proto-buffs? So what we're going to do is you take it, it's going to like serialize it into a binary protocol, it's going to put it on the wire. The great thing about using like XML or JSON is you can look at it and tell what it is, field name value. This is just a string. That's harder to look at, but it's also great for people like me who are trying to break things. So opaque and binary, love that. And the same bytes can be reinterpreted differently. So we're talking about if it's a 1, 2 different things can use that, but differently, because when it hits the proto buff, it pulls that type of data in. So great for interoperability, and this is what is actually good for is, let's say I update something later on, and I add like field 3. Old things that don't know about field 3, it'll just ignore it. So it's great for like interoperability, going like forward and backwards. But it also leads to type confusion, which means I tell it it's a 1, and I send it a value of 100. One thing thinks it's a temperature, one thing thinks it's humidity, bad things happen. And we're only going through really fast because it's the end of the conference. There's free pizza back there. You guys don't want to be listening to me. Okay, so this is a direct quote from me, and I say this a lot. My code is like an 87 Honda. Like, it's going to get you where you're going, right? We don't want to look under the hood. You don't need to know what's going on underneath there. So, what had happened was, David messages me, hey, you got a fuzzer for this? Yeah, we're going to make a fuzzer. I go out to Eclipse. Eclipse is the people who run the Sparkplug. I pull down their sample code. I take their sample code, I look at it, and I was like, oh, I'll throw like a word list in here. Not a big deal. But then my company, Bishop Fox, had just bought me a Claude license. So I take my code, I give it to him, he finds a couple findings. And I'm like, I wonder what Claude can do with this. Like, let's go bully this robot into doing some things for us. And it comes back and it's like, basically, you're dumb. Do you want me to do this for you right? And it's like, you don't know me. Yes, absolutely. So we're going to show this. But so like, this is our literal conversation here. He was like, hey, what can we do? And I was like, well, we can ask for an endpoint because you don't want to fuzz a live endpoint and break something. And he's like, it's a test environment. And I was like, please hold. And this is literally, I talk and write it the same way. Like, we're going to YOLO some Python. So this is the literal code. This is the before. This whole section right here, that worked by accident. Like, it only worked because I called that client.connect the second time. Like, that first one, that's not right. Obviously, it fixed it. I don't know how many people here have done threading in Python. I did it one time, and it worked right, and I copy and paste that. Like, that's one of the things where it told me, like, that's Python 2. Like, why are you doing that? We're using Python 3 now. And I was like, excuse me, one of us can shut the other one down. So this is all like the literal list of problems. I'd set up this wrong, the connection only worked by accident, my threading was bad. I only fuzzed 2 of the 19 data types because that's where I threw the word list in. Did I do a CLI? No, it was just a straight script. I didn't do the discovery. It's a self-mapping protocol. Like, as long as you're sending it, you can map the whole network. I didn't do that. And I didn't log anything. So when he had to go back and write the report, he had to like rerun it and capture the packets. So I swear Bishop Fox does better work than this. So how are we gonna fix this? And like I said, he used to be my boss. So I gave it everything. I gave it the protobuf file. I gave it my junk. I gave it the spec. And it's like, here's all the things you could fuzz. These 9 message types, 19 data types, 87 unique fields. And it asked me, like, do you want to fuzz this correctly? And I was like, yes. Don't shame me. And we're going through a little fast because we've got a demo. We're going to pop some stuff on stage. So it built the Sparkplug B helpers, which were great because Sparkplug B, it does the things that it's supposed to do in the way it's supposed to do it. Obviously, low-level stuff, the valid payloads are going to get accepted. Invalid payloads are going to get rejected. So we had to go underneath it to build that helper library so we could do things it wasn't supposed to do. That's being a pen tester, that's being a hacker. Like, what can I make this thing do? Not what it was designed to do. I've talked to multiple developers, and I'll be like, oh, I put a -6 in there. And their answer is always like, well, why would you do that? And I was like, well, why would you let me do that? Like, obviously, I'm going to try to break your stuff. Like, I don't even care that it gets broken. I'm just here for the chaos. So, and then we added a device tracker, which was basically, it would subscribe on the network with a wildcard name, and it would build out a map. We're going to show a map here in a second. It's the same network, but we didn't build that live. All right, so where did it help? Like this is where AI actually helped me. So what we owned, you can do AI. You have to know what an alias collision is, and not just an alias collision. AI is good at doing things that you tell it to do. It was good when I said, I want to go break this thing. You got to help me break it. Don't actually tell it like the guardrails will kick in, but you can lie to it. Lies are the lubrication society runs on, so lie to it. So recognizing that the OT bridge, so like bridging the two networks, like AI didn't understand bridging an enterprise data network into an ICS network. Bad idea. You just have to know that. And then where I did bad things, it like knew that. So it did well. It really did. Like I was never going to read that protobuf spec. It wasn't going to happen. My fragile loop, AI is like an intern. It's read all the documents. It codes really well, and it's really enthusiastic, but it doesn't know what to do. You got to guide it. So I kind of guided it to where I wanted it to go. Anyone here like love writing documentation? I was never going to do this. I was never going to write that README, and I was never going to write those documents. This guy, I don't know. So I have some ping pong balls back here. I'm going to find you. I'm going to throw a ping pong ball at you. So I don't know. So mermaid diagrams. Another guy that I work with showed these to me. So it's basically like kind of writes a markup and it spits out these diagrams. It was awesome. I was never going to do that. It was like, do you want me to write a mermaid diagram? And I was like, dude, of course. Come on. Like, don't ask me dumb questions. So this is what the mermaid diagram for the tooling. Like, this is literally what it's going to spit out. If we were running it for this setup, setup is I have a gateway running right here. There's 3 sensors in the back. Obviously, so there's an infrared, humidity, and a light sensor in the back there. And then it has the group names. One of them is called IAMHost. That's dumb name. As you can see, I'm super creative. My fuzzer node, it's called fuzz node. And then the EG4 is this default one. But if you run this on a huge network, it will spit this diagram out. And it would show like multiple nodes, multiple brokers, all the hosts, kind of everything you need to know. Because it's a self-mapping protocol, and it can draw pictures for you of a self-mapping protocol, you can take this to some engineer and say, look, this is where I broke your stuff. And in theory, they will fix it. So I got started in industrial controls. I mean, I was born at a very young age, and then I did some things, and then I did industrial controls. So I would make networks work. Like, my job wasn't to go back and make them work perfectly. Like, I got paid and given a certain number of hours, and everyone just is trying to make everything work. And unless you're like telling them to make people secure, I wasn't doing it. So I would not even blame these people, like, because these guys got it working, and that was what they were supposed to do. Oh, we got to go back 1 second. Okay, so the things that we're going to look for later. So N stands for node, D stands for devices. So there's things called berths. Shockingly, it's when you berth yourself onto the network. You're like, hey, I'm on the network. I'm getting ready to do things. And then there's also deaths, where you're like, hey, I'm done doing things. Don't listen to me anymore. So this is also a quote from me. Like, AI can't do things. Like, AI is never going to have that creative spark, that jump that everyone here can make. So it's like, I kind of know what I'm going to do, and I'm willing to take all these other parts, smash them together, kick them a few times, and poke it through the hole and make it work. Like, that's kind of the interface between AI and like consulting or pen testing or hackers, is you are the creative spark, and it is the thing that can help you get there. So also raise your hand, except for this guy, because he's writing documents. Like, raise your hand if you have a project that's like 70% done, and you're like, I don't know how to parse that data. Like you hit a wall where you're like, I don't know how to get there, right? Like that has outcoded me. So AI can help with that because it knows how to parse data. It knows how to like do pattern recognition. So use it for what it's good at, and also don't have it write findings for you, because I have to read people's findings all the time, and I was like, look, bro, you've never used the word surface or pattern in your life, so I know that AI wrote this for you, and stop. Like, because it's just slop. Don't send people slop. All right, so we're going to do demos, results, defense. So there's 9 message types. There's 19 data types. There's 87 fields. So this is the Monit gateway down here. If you are super creative and watch, you're going to see a couple ODAs get dropped right here. You don't have to be super creative. They're the ones in red. So basically, we're going to fire this up. And we are going to demo. So this is what you're going to see. You're going to see it. I'm going to come up and I'm going to impersonate this EGW4 gateway. It's going to send data before and after it's birthed. It's going to like do a death, but it's going to send data after its death, so it shouldn't be obviously run. We're not going to authenticate to anything. And then also like machine state, I'm going to publish things that I shouldn't, right? Like I'm not registered on the network, you shouldn't be publishing. I'm super creative, so this is obviously up. All right, so those are the sensors in the back. These are literally sitting on the speaker back there. You can see it's coming in. That's the real network over here. Let's make sure we're in the right pane. So we're gonna do so this is the full fuzzer. It's gonna run for about 15 minutes. We're gonna kind of chat as everything goes by. We're gonna talk about all this stuff. So it's basically blowing data out onto the network right now. Some of them say EGW4 with the fuzz node is the device type. Some of them say fuzz node with the fuzz device. Like those aren't registered on the network. I'm just literally making these up and sending them out. One of the things that kind of added on later on, you're gonna see like second order things come through here, which is, this data is useless on its own. So these get ingested in either a logging system or a human machine interface. See all those A's go by right there. So the other thing you're looking for is second order things like logging injections, like log4j. Old systems still use it. Like nobody updates their industrial controls. And if they go into human machine interface, those people aren't looking for cross-site scripting. Like they're literally just throwing it together. Right? So as you see these violations go by, I think there's some coming up. If not, I have a special one where it's only like the hotness. So does anyone have any like just general Sparkplug questions? This takes a few minutes to run. Like look at all those nice violations. So you also should escape like your terminal characters. So those ones that say red right there, like that is literally injecting code in that would force a terminal to print out red. And it worked, and I know it worked because I didn't escape it the first time I did this, and I was like, why is it in there? So like I was injecting myself. So there's,
excuse me?
It's a very good, so it's a unmanaged attack surface, which is great. If you would go out, not that I ever would, if you go out on Showdown, look for Sparkplug or MQTT. There's a lot of trucking companies that use this. So you can find this out on the internet. You could fuzz this.
I had a question about Sparkplug.
Sure.
Yeah.
Yes.
Yeah. So the question is, why was there no client authentication in the first place on Sparkplug?
Like, why was there no mitigations?
Yeah, no client authentication, because usually MQTT supports those kind of situations. Right?
Oh, it supports it. So, like, we're going to talk about it. It definitely the difference between is it supporting it, or did I do the bare minimum to make it work?
Oh.
And I feel like this network I got it working. Like, did I use mutual TLS? No. Did I do an authentication packet? No. And my personal opinion is, it's not Sparkplug's responsibility. They don't do authentication. It's MQTT's responsibility, but whoever did that isn't getting the sensor data from Sparkplug. So it's kind of everybody's responsibility to do it right. And if it's everybody's responsibility, it's nobody's responsibility. So like nobody owned that risk category in that company. So once they bridged it over from one network to the other, whoever owned the MQTT transport was like, that's not my data, that's Sparkplug data. And Sparkplug was like, I don't do auth, MQTT does auth. So it needs to be tracked as a risk. I mean, I'm gonna make some people like cringe here, but you gotta put it in your risk tracking register, you gotta do stuff right. Or not. Like I always tell people, so like if I'm having a bad day, clients are having a good day, right? Like if I'm not finding anything, you're doing your job right. If I'm having a great day, your company is having a bad day. Like Like it is a plethora of shells coming back. The term I like to use is I'm popping shells like a stripper turtle. So if I'm having that day, it's great. So we ran it all through, everything's stocked. We only want the really cool ones because that's what we're going to talk about here in a second. So that's the on-stage money shot. So these ones, basically publishing data before birth, publishing data after death, publishing data, basically spoofing data. So these are basically ODAs. Like you would go like to Monet and say, your MQTT is not like handling this correctly. So right here, did we provide any credentials? No. Is it anonymous connected accepted? Yep. And could we subscribe? Yep. Here were the 4 things that we found. I dumped out the log file. There's a picture in there. I'm not going to go get it and compile it because it wasn't part of the demo. Okay. So this is what we did. So it's not the defense layer. So I'm standing up here telling you how terrible Sparkplug is. Sparkplug did exactly what it was designed to do. MQTT did exactly what it was designed to do. It transported this. But it's a dumb relay, and that's fine. Sparkplug isn't the auth node. That's fine. The problem is you can do a few things. You can do these ACLs. We're going to talk about that. You can do mutual TLS. That's more on the MQTT side. Do you want to do client cert bound identities? That's a little difficult, especially as we're reducing the time for certs. Like a 90-day cert, rolling these onto all these devices, probably pretty difficult. And then you can do like host-side sequence validation. A little more difficult, but it's built into the protocol, so you could do it. So fixes are boring. I used to work at the government. I used to be on the blue team. Nobody likes fixing things. I like breaking things and giving people a report, and it's like, dude, your stuff is broken. You should go fix that. I gave you a couple recommendations. They're probably trash, but I don't have to work on it. I'm going to be on another client next week. So what did you do? So enforce TLS. That's probably like mutual TLS makes like pen testers' lives hell because we don't have that cert. Require auth and kill anonymous access. Those are like just basic kind of network hygiene. So topic ACLs are great. You can't impersonate another node. So I couldn't inject that fuzzer node and I couldn't inject that EGW4 if you didn't allow that. So also validate the protobuf and enforce data types. Like these are like for all of you coders who are like, you know, if we're looking for numbers, like and they're trying to send me letters, I just put a regex on there and reject the junk. So sequence numbers. Every time something sending a sequence number, if I'm starting at sequence 0 and you're expecting 4,000, like there's obviously something wrong on the network. Somebody should go find out why that device reset without doing it correctly. And then log these births and deaths. Because if births and deaths, if you're doing things before and after when you're not supposed to be, like either your things are broken and you should figure out why, or somebody like me is in your network just doing weird stuff. And then segmentate. Okay. Everyone, you just segment your networks off. For everything, not just for this. Like network segmentation fixes a lot of problems. And it is difficult. Network engineers don't like it. It adds time and effort, but it does fix a lot of problems. Okay. So we already talked about this. Sparkplug relies on MQTT for auth. And here's the types of auth that it can do. It can do username and password, probably the weakest, better than nothing. It's clear text. But if somebody's already sniffing your network and it's segmented off, you have bigger problems than this. Server-side TLS, great. Makes it harder. Mutual TLS, that's the strong option. Do that one. Also, it makes it where you're like, I know which certificate I gave to which device. And if that device connects, I know who it is. So do this one. And MQTT-5, which is the newest and greatest, like do that one too, because it does like challenge and response, and you can pass JWTs and tokens. It's a more mature, obviously fifth protocol. It's better. So the auth gap, this is really important. So it doesn't solve the spoofing issue. If you can get auth to the gateway, so like if I can just auth as this gateway, then I can just do anything that gateway is allowed to do, which is mostly just publishing data for all the devices that it's connected to. So because like auth doesn't fix everything, TLS doesn't fix everything, but if you layer them on top of each other with the ACLs and the auth, like it gets you farther. So birth and death certificates, that's where we really like killed it. So if the big issues we saw were publishing data before the birth certificate came out, publishing data after the death certificate. Also, when you publish your death certificate, it resets your sequence to 0. So that's why we were talking about looking for a sequence. Because if I reset the sequence to 0, and I'm not supposed to be talking on your network, and then you start getting more packets with either random or like all like one sequence, it gives your like incident response guys something to check out. So obviously, don't allow this. Like check these out, and I know there's a guy who just left to go do an incident response. I do not do incident response. I hate incident response, and if you do that, I feel sorry for you. There's a few things on my resume that I specifically leave out, and if people are like, hey Shad, can you do incident response? I'm like, I have no idea what you're talking about, and I don't know who you've been talking to, and shut up. It goes up there, it's up there with PCI ASV, and we're like, didn't you have that certification? I'm like, I have no idea who you are, why are you even talking to me? Don't make me get a restraining order. So this is how it works, right? Like this is kind of like just the high level. How it works in general, you send a birth certificate, it gives you the sequence to 0, everything's online, you send data, either node data, ins or nodes, these are devices. It tends to go like offline on this side, online over here, and as you send it, updates the sequence. Notice how I use the correct C++. So data before birth, bad. Data after death, bad. Duplicate and spoofed things, bad. And then aliases and collisions, which means I'm publishing something to a topic, let's say like the humidity sensor. If I'm publishing humidity data and then there's already one online, like why am I getting duplicate data? And all of this stuff is because it's in clear text and you're pushing it into either a logging system or a human machine interface, should be pretty obvious. And that the device doesn't, so everything. Oh, so the question was, does the device know the difference? And because of the way the protobufs work, it does not. It says, I am a device. I send field 1 a value of a 100. Field 1 in the protobuf, when it comes online, it tells them, I am a humidity sensor, and field 1 is humidity, field 2 is like the value. So it doesn't know it's humidity. And when I'm fuzzing stuff on your network, I don't care that it's humidity. I'm just blasting things out into the ether. So that's why it's such a like ripe target for fuzzing, is the way they smashed it down to make it a very lightweight network protocol, kind of abstracted the data. So it's not like JSON where it's like, you know, humidity, values, temperatures, fields. Like it's much more compact, which makes it great. But also like removes some of the information that you and I could look at. Did everyone get that? Did everyone get the question? We can just jump in. You can just like yell at me, throw something. We're going to talk about like kind of like why industrial protocols, like why we chose this one. I chose this one because David Collion said, hey, can you write a fuzzer? But we slapped this slide together, so there was no public fuzzer. We wrote a public fuzzer. So there's the GitHub. You can go there. You can get it. I have a PR in. I'm not allowed to push to my own repo. So I don't know if they did it before this conference or not. It has a couple of fixes in it. So I wrote a blog post. So I made Claude. I bullied the robot. I took our like formatting. Here's what our blog posts are supposed to be. I took my notes and I was like, hey robot, write me an outline, and it wrote me an outline, and then I slapped it together. So like I said, don't let robots write for you. Also, find me later, because I might already be fuzzing your protocols. And if not, if you're like, hey, I got S7, if you're fuzzing S7 and you want some more O days, I got some. But like, if you're like, hey, I'm doing Alan Bradley, I'm doing Genius Bus, like, come find me. We'll write a fuzzer for it. Like, I don't know if you can tell, I like breaking things. So break your stuff before somebody else does. Like, one, because there's a lot of bug bounties out there, you can make some money. And two, you don't want bad guys doing it. We're going to talk about some bad guys here in a second, and kind of the two categories of bad guys you got to be worried about. All right, before you go get pizza, so there's two types of bad guys that you're going to be worried about, because you're like, I don't care about industrial controls. I don't do industrial controls. So you have nation states. How are you going to prepare the battle space is what they're going to do. So Stuxnet, what they did was they ran the centrifuges a little too fast on and off harmonic, broke the devices. This is what you do with these. You tell it, hey, your humidity isn't 52%, it's 54%, and you run it a little too hard or a little not hard enough, and you like ruin devices. Or I believe maybe a month ago, 6 weeks ago, they dumped too much chlorine. I believe it was totally not Iran. Dumped too much chlorine into a water treatment plant. Like, this is the sensors that you would do that with. You'd say you have X percent of chlorine, and it's either too high or too low, and you get the system to change it. So these sensors feed into systems that feed into real devices, usually valves, controllers of some sort, and you can mess with those processes. So if you're not a nation state and you're just a jerk. So the reason you can buy those temperature sensors is because they put those inside container crates, and they ship them for, it's called cold chain, which is a lot of medication, a lot of food, where your temperature has to remain between a certain time in the entire transportation. And I'll just say, oh yeah, you were 31 degrees, just how you're supposed to the entire way. And now you get your container somewhere, and now you got a bunch of bad bananas. Does it ruin anything? Does it ruin like somebody's day? But it costs money, and it just lets you be jerks. Also, don't be jerks. I eat a lot of bananas, so like. So it's a real problem. Also, like, let's go fix problems. Actually, I'm not. Let's rephrase that. I will find problems, and somebody else can go fix those problems. You don't want me to fix your problems. Have you seen my code? I couldn't even get those loops to work right. So I'll break it. You guys fix it. We kind of burned through this a little bit quick. I know, because there was pizza back there. It got delivered early, and we wanted to get you to the pizza. It was my company that paid for it, so I'm supposed to shout that out. So go get pizza. If you don't have any questions, we can answer them right now, or you can find me. I'll be wandering about, and I'll answer them then. I'm here all night, folks. Tip your waitresses. So.
Yeah, we can do let's just. Oh, you want to? I guess Mark's here, the real parent. We don't know. It's fine.
Hi,
Just take this and I'll use the one.
No, I see it.
question.
Question.
Okay, question. We're doing it.
Yes, we're doing it live. Okay.
Have you looked at these controllers for AI data centers before?
From data center, like directly from a data center? I have not. So most of these are usually live like off networks. Like they're supposed to be in industrial control networks. If you look at critical infrastructure protection, one of the rules is segment it. Like keep all of your critical information away from like, your email network. I haven't seen that, but I have seen at a lot of oil companies, we'll bring them into like a specific like POP, and then like host the data in kind of a data lake there, and then usually use like batch jobs to push it into like a production network where they can like run transforms and stuff on it.
So I can tell you I've seen some, and they talk to Microsoft IoT Gateway in Azure, and they speak the same protocol that you're trying to break.
So I'm not sure about Sparkplug exactly, but I do know those temperature sensors that live at the top of server racks. I do know that they are basically an IC protocol that runs over like KVM or something,
Yes.
right? So if you know that protocol, we should talk. Let's go break it, pop some O-days. So, we'll get a couple drinks in both of us. Nobody will remember who said what. So,
Yeah, we'll continue this.
we're all gonna go to jail. So,
We'll continue this at the bar. Seriously, there's a drink to it.
yeah.